Whether by land, sea, or air, military dominance is always won by command of the highest ground. The Space Force Association works with industry partners to examine what's in the art of the possible for future capabilities. The SFA provides an opportunity to research, inform, and advocate for a strong Space Force. Show your support by signing up today at ussfa.org.
For more than 60 years, space sensing technology has stood as a cornerstone in our nation's defense, upholding global security and solidifying a secure future. However, strategic competitors are quickly developing and fielding more advanced and diverse missile capabilities, threatening to tip the scale of our military advantage. Most imminently, China and Russia are fielding a new generation of hypersonic low-flying missiles that are more difficult to detect and track, while also demonstrating the ability to deploy anti-satellite weapons. This scenario demands a cutting-edge ground system capable of collecting data from diverse sensors and swiftly processing it into actionable intelligence to counter these evolving threats at unprecedented speed. Future Operationally Resilient Ground Evolution, or FORGE, is the modern ground system that will transform the missile warning and tracking architecture. It is the next generation ground system that supports legacy and future OPIR systems, providing the modern infrastructure and digital platform needed to turn data collected from space-based sensors into actionable information in support of national security objectives at immense speed.
Most recently, the FORGE program, under the Strategic Missile Warning Ground and Integration Acquisition Delta, achieved the initial operational acceptance of its Mission Data Processing Framework on April 26, 2024.
Increased cyber resilience and mission applications that bolster the OPIR battlespace awareness and technical intelligence missions, including enhanced missile detection and tracking, was delivered to the OPIR Battlespace Awareness Center. This includes modernized sensor processing and algorithms able to better detect and report dimmer and faster moving targets, as well as track missile threats earlier and longer, improving the event custody chain. Looking ahead, the FORGE team will continue its progress towards building a government-owned, modular, and open architecture, enabling us to leverage the latest industry innovations and rapidly respond to adversarial threats, providing a secure future for our nation and allies.
Hello, everyone, and welcome to another Spacepower podcast. I'm your host, Bill Wolf, the president and founder of the Space Force Association, and honored to be the only association solely dedicated to the U.S. Space Force, Guardians, and their families. Speaking of Guardians, we're honored today to have with us Colonel Rob Davis, the Space Sensing Program Executive Officer out of Space Systems Command underneath the United States Space Force. Colonel Davis, thanks so much for joining us today.
Thanks for having me, Bill.
Before we get going, I'd like you to provide an overview of your PEO and talk a little bit about it, and then we'll get into some of those questions. So, sir, if you don't mind going through a quick presentation so folks can better understand what you do at Space Sensing.
Yeah, happy to. Well, first off, Hippie, thanks for the opportunity to interact with you and the Space Force Association. I think it's a great opportunity that you're providing for us to share what the Space Force and Guardians are doing. I'm super proud to share what my team is doing. They're super busy right now. There's a lot going on in the space sensing mission areas we'll talk about here in a bit, and they're getting after it. So as you said, I'm the PEO for space sensing out here at SSC, supporting the senior acquisition executive, currently Major General Purdy, out the Pentagon there, and we're charged with the capability development, handing that off and fielding those capabilities to our partners over in SPOC and other organizations to take that capability to the fight. So I did want to spend some time, as you asked, to kind of go through what is PEO space sensing, what does the team do out here. But before we do, I think it's really important for me to start with why. Why does space sensing exist in the first place? Why do we start with why? So the biggest thing is I can say is we're in a race. We are in a race against several willing and able adversaries, potential adversaries, some competitors out there that are doing everything they can to take away advantages that we have, that we've provided for the nation for quite a while. As many of you have seen over the decades, SMC before us and now SSC has a long history providing amazing space-based missile warning capabilities to detect and then warn warfighters downrange to be able to protect themselves, and more recently, as technologies evolved, to defend against threats. And just a kind of a notional example here, you can see on this chart on the right side there, just for a long time, a lot of activity across the globe and missile events every year that the systems are seeing and detecting. But you can imagine, in Ukraine invading Russia, and then some Iranian events we've seen against Israel, how those numbers of missile events have just increased over time. Nations have seen, what the United States Air Force can do and the Navy in bringing air power to the fight, and they've gone in different directions, and sometimes investing in ballistic missile technology to be able to still try to have an effect against our forces downrange, against our allies, and potentially against our homeland. But we've gotten really, really good at detecting those missiles, figuring out where they're headed, and passing that off. And that's super evident by the couple of times now where we've had mass volleys of missile attacks from Iran into Israel, and just the amazing capability. Obviously, the Israelis built out amazing capability, but we have amazing capability too to take that information that we, with our OPR systems, detect those missiles, pass on, and allow those intercepts to happen. And in both cases, there's tremendous ability to defeat that threat. And everybody's read about that. There's been some recent articles from the Space Force about that. If you haven't seen those, I encourage you to look at how the machines, how the people, the operators, the guardians operated those machines, were able to do that. But very, very, very good. The problem is the bad guys have seen how good we are at seeing those relatively simple ballistic missile threats and how we've been defending them. So in that race, they're looking to do other things. We've all heard about hypersonics. We've all heard about maneuvering vehicles, things that are trying to figure out how to defeat our ability to not just detect where those launches happen, but where they're going to impact, to be able to guide our interceptors to be able to take out those threats before they do the damage they're intended to do. So a lot of intel out there about what the Chinese, the Russians, other state actors are doing here. Even trickled down proliferation of this capability. Some of it's harder than others, but you're seeing a lot of it out there in the globe. And so we have a significant increase in the threat of the missile capabilities. And that's really one of the impetuses for why we're changing how we're doing business in missile warning. And we'll talk more about that in a little bit. The other big thing that everybody's been hearing about in the race is the counter space threat. So we have long had a great geo architecture, some assets in HEO, and there's a reason we put those assets in those domains, right? There's lots of good things about geo. Well, some of those same things that are good about geo for why we put those assets there also make it vulnerable. It allows adversaries to feel capabilities there in an attempt to counter our threats, or counter our ability to do that sensing with their threats. So we're having to think differently about how we build an architecture that can be resilient, can enable us to fight through the whatever they throw at us, making sure we can still provide this important capability to the nation. And so you can see how we're trying to really focus on that why every day in the portfolio and space sensing. The portfolio and space sensing, as I've alluded to a couple of times, is made up of that missile warning capability and that missile tracking capability, along with partners we have across the interagency with MDA, and also within the Space Force with Space Development Agency, with SDA, but also has space-based environmental monitoring, so weather, and a new mission area called Tactical Surveillance, Reconnaissance, and Tracking, TACSRT. So kind of a diverse portfolio there with one focus in mind. In the race we're in, how do we stay ahead of the competitors to be able to field capability to our partners in SPOC and elsewhere, to be able to stay competitive in the fight, both in the missile warning area, in environmental monitoring area, and that newer area, helping combat commands and the tactical surveillance reconnaissance tracking. So I'll take just a little bit more time to step through each of these and kind of give a sense of where we're headed and how we're thinking about this race in each of these areas. So today we have a very robust global missile warning architecture, but largely against yesterday's threat, and not against the emerging threat that I just talked about, both in the missile technology that other people are fielding and we have to track, we have to be able to see and track, but also be able to defeat any counter space threats that a competitor might decide to throw at us. So very robust in the geo regime, in the polar regime, to be able to provide that global coverage and that coverage of the poles to have that view where we need to be. Also relatively robust on the ground, predominantly CONUS though. We do have some elements overseas and JTAGs to provide regional support to combat commands, but we have that element that's against the threat as well. But we need to evolve both of those. So what are we doing about that? Now this chart's really busy, and I don't need to, try to brief every element of it, but the key here is there's a lot going on in this mission area, and it's because of those two things. How do I get better at seeing and tracking advanced missile threats, and how do we make sure we have an architecture that's able to fight through, near peer competitor type engagement, right? The war in space that hopefully will never come, but may come someday if somebody tries to take away the great advantages that we have there. So what you're going to see is a pivot away from that geo and polar coverage through a HEO orbit to proliferated architecture, both in LEO with our partners at Space Development Agency and with ourselves here at SFC in the MEO layer, providing that tracking coverage as well. You're also going to see increased resiliency on the ground. We're spending a lot of time on proliferating the space architecture, making sure that we have a robust and resilient architecture there. We do the same thing on the ground to make sure we're keeping pace overall with the threats to that ground architecture. So we have an overall system of systems architecture that can survive in the face of a willing adversary. So a lot going on here, a lot of investment, a lot of time and energy to make sure the nation keeps this capability going against the new threat and to counter the new threats in the counter space area. Switching gears a bit here, we have our space-based environmental monitoring mission I mentioned earlier. A lot of activity going on here as well. We recently launched in April the first weather system follow-on microwave capability. So that was exciting. That was the first new DoD weather satellite in a decade since the last DMSP launch. So that's pretty exciting news for the team here. What we've done is taken that DMSP heritage that had a microwave capability to be able to do things like surface wind speed, sea state characterization, tropical cyclone intensity for many customers around the globe. But it also had an EO/IR sensor on it to do cloud characterization, theater weather imagery, things like that. That was all on one satellite, DMSP. For lots of different reasons, we've just aggregated those capabilities. In this case, the microwave capability on WSFM. And we're also in the process of actually building out right now an EWS, EO/IR weather system satellite to field for that element of the architecture as well. We're going to build 2 satellites, each of those, and then we're going to pivot to the future architecture, which we're kind of exploring right now. So again, lots of activity going on here. Really thinking about how we also incorporate commercial emerging capabilities here. And I'm looking forward to talking more about that later on. Lastly, tactical surveillance, reconnaissance, and tracking, our newest mission area, and probably our most exciting. Just total opportunity here. That's what makes it so exciting. We are out there with commercial industry looking at ways to take emerging commercial data analytics capabilities that are existing in the marketplace for other purposes, taking commercially available information, publicly available information, having that commercial data analytics, process those to help answer questions for warfighters. So our component field commands around the globe will interact with command commands. There's a problem to solve, a question to be answered. We're, bring it to TAC SRT. We'll go to our commercial data marketplace, quickly ask that question, quickly get one or more vendors to go chew on that, using their data analytic tools and provide that information back to the warfighter for their use. We're still in the pilot phase there. We've been in that pilot phase for a while now, but we've had over 400 products delivered supporting over 75 events, operational events between humanitarian assistance, disaster relief, border monitoring, a lot of opportunity in different aspects here to provide commercial capabilities to the warfighter in a completely unclassified way to be able to quickly get that in the hands of the people that need it. And that may be partner nations, that may be the intelligence community to be able to take that data and tip and cue other assets against it to do further refinement, or maybe straight to the operational community to make decisions off of. So very excited about this. The chief's been talking about it a lot. He's highlighted our Airbase 201 support in Niger. I don't need to go over that entire thing again, but suffice it to say, this was a crucial capability that we brought to the fight. The Space Force brought to the fight, even the pilot phase, to support that operational withdrawal from Niger and that airbase to keep all of the Americans on the ground there safe through that event. So that's why we're here in space sensing, hyper focused on winning that race against that willing and able competitor or set of competitors, keeping our eye on the ball there. And I'm looking forward to having a conversation with you.
So much for running through that presentation. It really is enlightening. What I especially appreciate, and I'm sure our audience will as well, is talking about that threat. And it's not often you see presentations like this coming from the U.S. Space Force where the threat is actually incorporated into the presentation. And that's, I think, really important for the American people to understand is we are in a threat environment. We have state actors that want to take away our capabilities. So how, if you could summarize, and I know you talked about this in your presentation, but if you could summarize, how are you ensuring the space warning architecture is as resilient as it can be?
Yeah, great question, Hippie. And there's a reason I start with that why, for all the reasons you said, right? It's not just, motivational talk for myself, for my team or whatever, but really at the end of the day, that's why we're here. And that's why the architecture is pivoting the way it is. That's why the nation's investing the resources that it is to pivot its architectures against that threat, those missile threats that are getting advanced, and then, obviously the counter space threats as well. So this, at the end of the day, following that logic trail, right? This is ultimately about how do we reestablish that deterrence by rebuilding the military to be able to deter and, if necessary, win if deterrence fails. The Space Force has really highlighted why we exist, and that's against this threat. Because if we don't succeed against this threat, the joint force will not be successful. We aren't just a supporting role anymore. We're integrated into the joint forces capabilities to project power across the globe and make sure that we're meeting our nation's interests, or if absolutely necessary, to help protect the homeland. So we're moving really fast to field those combat-ready forces. A lot of different ways we're doing that. You saw the proliferation. We're doing innovative things on the acquisition and capability development side in the terms of really doing good enough architectures, doing non-reoccurring engineering. So trying to leverage commercials. We're not spending years in design of military unique capabilities, trying to make those spacecraft as small and expensive as possible, because we found that if they're larger, that tends to drive schedule and cost, and it allows us not to be as responsive to the threat as we need to be. So, obviously, Honorable Kelly has since left to being the SAE, but we're still definitely taking the leadership legacy he left, and we're continuing with that mantra, those tenets that he laid before us to make sure we're getting after it. We're obviously taking that proliferated architecture, dispersing it between the multiple orbits. So that's a key component of the Space Warfighting Analysis Center SWAC's force design, having those multiple layers there. And we're, along with our partners at SDA and MDA, we're getting after fielding those two layers, both in PLEO and then the PMEO architecture, to have those proliferated architectures. We're also, not to be forgotten, we're also investing a lot in the ground, in the force system, to make sure there's resiliency there. I mentioned that previously, how important it is to keep the architecture as a whole resilient against the threat and not overly focus on one segment or the other. So Forge is bringing resiliency in the terms of cyber primarily. It's being purpose-built ground up with modern software practices in mind, and significantly increasing our ability to protect the ground system of the missile warning architecture against cyber.
Yeah, and so your point is, with the three segments you've got, the space segment, the data segment, and the ground segment, all of those are equally important. You can't do the entire architecture without each of those critical components. So let's talk about the ground segment for a moment. And again, on that slide, it depicts a hypersonic, what I presume is a hypersonic coming in and potentially taking out a critical node in that architecture. So how are, describe again that ground segment capability and how you're ensuring that it's doing its job within the architecture.
Yeah, ground often kind of gets forgotten in this, right? I mean, and even the pictures I saw, the OV ones I showed, right, of the architecture, you see all this activity going on in the space segment, and it just consumes the visual of the architecture, and that's a great representation, unfortunately, of how we often forget about the ground. And so we've been really trying to focus on how do we make sure that we don't do that. I mentioned Forge. That's a huge element of the missile warning architecture on the ground of the future. We're actively deploying that. The first operational delivery was to the OPR Battle Space Awareness Center, the OBAC, in the 11th Space Warning Squadron at Buckley. And so that's in ops today. And we're in an incremental delivery of that capability to further out the baseline capability set there to replace the SBIRS ground architecture. And Forge will bring in sensors, both the legacy sensors and MEO and LEO sensors coming down the pipe, and anything else that comes in the future to fuse all that data. And once we establish that baseline, we're going to keep in that DevSecOps pipeline to keep resiliency going throughout the development cycle, right? Hand in hand with our operator friends and partners to make sure that we're keeping up with that threat. And then we have to think about, and this is very early, we're kind of starting to think about now, is how do we, from a physical infrastructure perspective, how do we make sure there's resiliency there? We have Buckley today, we have Schriever today for the legacy SBIRS architecture. We have the J tags around the world, the foresights around the world. We're in the process of fielding the SBIRS survival and durable element S2E2 right now as we speak, getting ready to IOC that here this spring. But we got to figure out how we make sure we keep that physical architecture resilient against the changing threat as well. So we're looking forward to getting after that. A lot of thinking going on actively right now in that area.
Yeah, and perfect, sir. And again, you talk about Israel, and as we are seeing recently, Israel has demonstrated and delivered and deployed a pretty phenomenal capability. And this administration's talking about a very important role here in the U.S. in terms of the Golden Dome. Take it. We talked about the Iron Dome in years past, but now we're talking about the Golden Dome. So I'm sure you're right in the middle of describing how space is supporting the development and eventual deployment of a Golden Dome technology, realizing there's a lot of components involved there. So can you talk a little bit about that?
Yeah, obviously it's an urgent and top priority for the Space Force, and Space Force is going to play a central role in this. We at SFC are heavily involved in the technical integrated planning team at headquarters, and we're working diligently with them to make sure that we're preparing our input to the DoD so the DoD can respond back to the president on our thinking about how to get after that. Here in LA, through all the different organizational name changes over the last several decades, going back to the 70s, this is the center of excellence for our nation, for the government's team, and frankly, in the South Bay area here, the contractor teams that have developed all the way back to the early DSP days in the late 60s, early 70s, built and fielded our nation's missile warning capabilities. So there's no doubt in my mind that we have a lot to bring to this conversation, and there's certainly no doubt in my mind that we're ready to do whatever the nation asks of us to keep fielding capabilities to protect the homeland and protect our troops downrange and our allies and partners.
Yeah, and what people don't realize, I don't think, when you show the OV1s, is it's representative of a capability, and the picture is a single satellite. The fact is that's actually multiple satellites in the constellation that are providing that capability. So as you start to proliferate multiple sensors into various orbital regimes, how do you deal with that amount of data? Because there's a ton of data now coming in. So how do you manage that?
Well, I don't want to keep, kicking this at horse, but it's how central the ground is.
Yeah.
It's always been important, but it's going to be even more important to your point with all these sensors coming down, right? The ground's where that's going to come together. And so it's entirely something we need to keep focus on. It's super crucial to the success of our pivot to this resilient architecture, our ability to track these dimmer hypersonic targets. And we're using Forge as that program that's delivering that baseline and many different elements of that to make it happen. I mentioned it's in ops today. That's the Forge framework. That's, if you will, in my simple brain. I'm a small thinker sometimes, so I try to put things in simple terms for myself so I can understand them. But if you think of the Forge framework as the computer and the operating system, so here on my desk I've got a small piece of hardware, and I got Windows running on that. That's the framework I'm running on. Then on top of that, I've got what we call apps today in modern lingo, right? I'm going to have a C2 app that's going to do the command and control of those assets, both the TT and C, the sensor management, whatnot. Then I'm going to have a mission data processing app as well that's going to take all those inputs from those satellites, from those sensors, do the data processing and fusion to be able to provide a 3D track into our messaging so we can send it to our customers downrange, be it ourselves on the strategic missile warning side, sharing it with our MDA friends and the missile defense mission they have, or with our IC partners as well. And we're going to keep that architecture, like I mentioned earlier, in that very agile environment where we keep that DevSecOps going hand in hand with our operators to make sure we're keeping up with the latest threats, the latest targets, making sure we're doing the right enhancements when the technology comes down with some AI/ML and things like that to make sure we're continually improving it against those missile threats. And we can do this because, unlike the past where we've had one big prime contractor, take Lockheed for SBIRs, like having one big contractor that's developed both the space segment and ground segment, and we're partnered with them for a long period of time, it doesn't create the same agility we have today. And so we've had a much different architecture from a ground point of view. We have a much more modular system, and it's a systems of systems and a program of programs, several different acquisition programs in there to be able to compete those capabilities separately, to be able to match those capabilities with the right vendors. And since the government owns that architecture, it gives us the freedom to do that. So the biggest thing we're doing there is changing that architecture fundamentally, making sure we have that foundation set. And then how do we bring in new emerging sense-making technology, AI/ML, other advanced algorithms to further enhance our ability to handle that big data problem?
Yes, sir. You mentioned AI and ML. We saw recently the Space Force just put out its AI strategy document. So talk about that. I'm sure you're getting after it, and but it's difficult. People say we're using the term a lot, but how specifically are you getting after that?
Yeah, thanks for asking. I'm super excited about this one. And it's probably one of the areas I'm most excited about. So we have a OPIR tools application and process lab, TAP lab in Boulder. And their job is to be that laboratory environment for our ground, our data exploitation. And so we've really asked them to think about, how do we employ AI/ML technology in our mission area. So we have a big data problem. We get a lot of data down, and we got to make sense of that quickly, and then get that messaging out, get that information out to the warfighter. So a couple of different steps here. I'm thinking in a crawl, walk, run, sprint phase, because again, I'm a simple guy. So in our crawl phase, what we're really doing is thinking about how do we help augment the operator when there's a lot going on. The system, the people did wonderfully with the recent mass threats, but we could do better. And so how do we think about these tools to further augment them to be able to keep pace in those high pace environments, right? And with the high threat environments, a lot going on all at once. So we're doing that operator kind of in the loop today. How do we help make sure that we continue to have them available? It's important to have an operator there, but maybe switching in certain cases and we're on the loop as the pace and those volume things pick up. And so we can keep the mission going and keep the information flowing downrange. So that's crawl. How can I do that same thing in my battle space awareness portfolio? I mentioned the OBAC earlier. There's a bunch of grid guardians there taking this data, this OPR data, and exploiting it and picking out other things other than missiles to be able to exploit that battle space awareness sight picture, right? And be able to pull other information out of it and get that downrange. And can't talk too much about that there, what we can see and everything, but let's just say it's amazing what you can do with this data. And so how do we help further augment them when they're on console, when there's a lot of stuff going on? And then this is where it gets a lot of fun, right? And that kind of run phase is my hypothesis is I'm dumping 90% of my data on the floor every day. We're getting all this sensing data down. We're looking for things we know are there that we've built exquisite algorithms for to pick out of all that and present to the operator. The operators say, yep, that's a missile. That's a whatever we're looking at. And they release that message. It goes down range. But what do we not see in there? Because we don't have the right algorithms today. How can we harness AI ML and on that other 90% of the data, or whatever the percentage is, to go deeper in that data? What other battle space awareness things can we pick out there? And how can we contribute to that sight picture for warfighters downrange on, what else is happening in their area? And then the sprint phase, you can think about, even more advanced things. How do I start doing some of that more machine to machine? You can think about long range kill chains and the timelines you need to close on those, right? And the importance of those. You can start doing machine to machine, incorporate AIML, right? Obviously, these are very out there kind of ideas, a lot of work to do. And that's why we have that laboratory environment. So we're actively playing around in the lab right now. We're failing a lot. We're learning fast because failure is good in the laboratory environment, but we're also coming out with a lot of successes. So I'm really proud of that team. They've come a long way in the last 6 months of really diving into this. And it's really exciting what they're doing and how they're going forward.
And you're talking about teamwork, and again, there's probably no better team than the U.S. Space Force with its size, and because of its size, its ability to be agile. And I know there's been discussions, recently about the ops and acquisition community. I don't see a line between the two. I just see a bunch of warfighters, outside
Yep.
looking in. I just see a bunch of warfighters. So how are you working with other warfighters to ensure that you are getting that capability to operators to ensure like your integrated mission delta concept is actually coming into fruition where you have that feedback loop?
Absolutely. You hit it nail on the head. We're all guardians first. We're all here for the same reason. The Space Force was created for a reason, and to get after that threat. In our case, we have a couple different threats, both the missile threat and the counter space threat, at least in the missile warning missile area. We'll talk about some of their mission areas later. And we're very dedicated to that proposition there. So we're super close with our SPOC and, in our case, Mission Delta 4 partners. It was a CSO priority, as you mentioned, with integrated mission deltas, to think about how we align readiness generation differently than we did historically. And so yesterday, there was a commander that was responsible, at least on paper, for readiness, but he owned the people, but he didn't own the equipment to maintain that, sustain that capability, right? And generate readiness for the equipment. That was over on the SSC side. In the case of Mission Delta 4, I own that. I had a team that was sustaining those capabilities. Now, in our case, and I think every case I know of, quite frankly, there was a seam there technically between that leader in Delta 4 then, before the Mission Delta stood up, and the sustainers in SSE, but you couldn't see it. It was really, really tight, super strong relationship. But there was still a little bit of a misalignment and responsibility and lines of authority. So the Mission Delta helped clean that up. And we've taken, in this case for me, the sustainment functions for that missile warning architecture, transfer that to Mission Delta, so Mission Delta 4 out of Delta 4. And now you have that one leader that's responsible for not only the people readiness generation, but also the equipment readiness generation. It's all aligned. But that did move a seam a little bit, right? It created a new seam between the sustainment function and SSE here. And me as a program executive officer, I'm technically still responsible, cradle to grave, for these weapon systems. So I'm still responsible in some capacity for the sustainment of those weapon systems. And so it requires us to stay super close on that sustainment function. But that's not enough, right? We have to also stay super close or get super close if we weren't before on the capability development area. And that's what we've done. About a year ago now, we've started kind of every 2 months to a quarter, depending on just how schedules work out, meeting shoulder to shoulder with my counterparts at SPOC, my counterparts at MB4, our leadership teams respectively, both the SPOC, MB4, and my leadership team, getting together for what we call a unity of effort meeting. And the first time, quite literally, was kind of getting to know each other, briefing current status of programs that SSC was in development on, making sure we establish a common baseline, having MD4 do the same. But through the 5 or 6 of those we've held so far, we've taken it to the next level each and every time, building that stronger and closer relationship to making sure we're partnering together to field those combat ready forces. And we learned some interesting things. We've had to learn on our side, on the acquisition side, this whole thing called SPA4 Gen. And as we're developing capabilities in a more agile fashion, a more frequent fashion than we ever had before, how do we align those deliveries with the SPA4 Gen cycles to make sure that we get the right training done to be able to actually field the capabilities? It's not enough for the widget to cross over to SPOC, but they have to actually be able to employ it, have the TTPs developed, trained, ready for the fight. And we've had to make conscious choices at times to think about, okay, well, here's the spot for gen cycle. Here's where I naturally be ready to deliver this capability. What do I need to adjust to make it work? Because it's not enough, again, like I said, just to deliver the widget. So that's been a huge eye-opening experience for both sides, because we've had to think about it differently on our side. They've had to think creatively on their side about what, in that spot for gen cycle, what do I need to do training-wise to adapt? How do I, in that cycle, adapt to if I'm making incremental improvements to a system, how do I have training that keeps up with that? So we're not having to wait for a whole spot for gen cycle each and every time I do a subtle incremental update to the software. So lots of stuff to think about there. Another great example is our ability to flex on the requirements in the agile environment. So on Forge, we're getting ready this summer to deliver the next application of capability to the OBAC. And then shortly after that, another round, another 6 months earlier or so. And the request came in, say, hey, Leo's coming down the pipe. SDA is doing a great job. Had success in T0. They're getting ready to start launching Tranche 1 here a little bit later than they'd planned, but they're getting ready to start putting those assets up there. So how do we make sure we get that data in the hands of the MD4 Guardians so they can exploit that data in their missile warning job jar? And that wasn't, we always had that on the horizon, but was never currently in the baseline plan. So that ask came from Spock and MD4, and we were able to work through this partnership to sit down and go, okay, we can do that. Here's what that means. Here's what we have to reprioritize. Here's what the schedule implications are. Here's requirements we might have to push out. And through that dialogue, through that partnership, we were able to optimize the delivery of combat capability to our operators so they can support those warfighters. So super powerful. The only way we're going to get after this is continue to partner and to be able to move at speed necessary to keep pace with the enemy.
Sir, thanks so much for going over all of that detail. What I really appreciate you talking about is the TTP development. And so as the Space Force continues to evolve, it sounds like you are right in line with the testing, tactics, training process that is known by every other military service, in that as you deliver the capability, you have to have the tactics to be able to employ it. But before that, you've got to test it out to make sure it can support your operational needs. And from there, the tactics are created. And then you take those tactics and you run it through an advanced training environment so that the entire community can learn based on that training environment. So it's really cool to hear you talk about that process that you're working through. Transition to the rest of your portfolio. You highlighted your weather efforts at the beginning. Can we talk more about development between commercial, civil, and DoD space?
Yeah, a lot going on there. I briefly touched on this in the last part of the previous question about partnering. And, it's very, very true in the SBEM, the space-based environment monitoring area as well. Excuse me. The partnering to win is a little bit of a cliche, but cliches, they get known for a reason, right? Because there's usually a huge nugget of truth in them. And so, little known fact, in the SBEM area, about 90% of our requirements for military requirements for weather are met through what we call the family of systems, which are civil systems, not just from the United States through NOAA, but around the globe, other nations, versions of NOAA. They have a consortium to provide this civil weather data in that partnership, right? Because weather is a huge element of good, and weather prediction technology is a huge element of good for mankind and stuff. And so there's a consortium that shares that data, and we leverage that capability to meet military unique requirements. Our systems, in turn, provide that data through NOAA, and they share that as appropriate as well. So a lot of exploiting, if you think about the exploit buy build model in weather today. Commercial is a new and emerging area. So how do we think about leveraging commercial to further advance our ability to meet those requirements and also provide resiliency? Resiliency is not free. And so how do we find innovative ways to defray those costs and make sure that they're affordable as possible to provide that resiliency? And SBEM is a great area for us to figure out how to get after that. And thinking about that in terms is really making sure that we're being mindful in our requirement set, and how do we not get the better being the enemy good enough. Usually we're very used to these very exquisite requirements that force us to go build these exquisite systems. How can we work with commercial to understand their capabilities? How do we change our requirements in a way that allows commercial to satisfy them, hypothetically, as a fraction of the cost? So that's what the commercial strategy in general is all about. then how do you apply that to a capability area like weather? Well, like I said a second ago, there's these government organizations around the world that make this weather data free already. So there's not a vibrant commercial market there for space-based weather, like there is for SATCOM, like there is for remote sensing, what you see on Google Maps, things like that. And so it's a bit of a challenge for us to figure out ways to potentially seed commercial interests in this area. How do we get them to start thinking about our requirements, developing capabilities to be able to meet our requirements? And then how do we also incentivize them and the investors they depend on to invest in their company, invest in their business model to scale to meet our requirements on the global scale that we need? And so we're thinking about that a lot lately. It's kind of a chicken or egg problem. I would love to go buy commercial weather data. There's no commercial weather data market right now, or very, very nascent. And so how do we work with the commercial market? How do we work with policymakers, the Hill, to create incentive models there to enable us, when we're going to need that capability down the road to be able to leverage that commercial market?
Yeah, thank you, sir. And what you did is you talked a little bit about the fact that there is a need out there for commercial, a continuing partnership opportunity with commercial. So I know a lot of times what we've got our partners in the space community are listening, and they're always trying to figure out how can we help. There's a lot of technology that's being advanced. So if folks want to help you, commercial partners want to help, what is the best way to reach out to you and your team if they believe they've got some capability that you absolutely need to see?
Yeah, come find me. I'm on the conference circuit, if you will. I usually, the only reason I go to those conferences is essentially is to meet with industry, to have these exact conversations you're talking about, to figure out what's out there, what's available to be able to partner with. Again, the only way we're going to keep pace with the bad guys is to keep that constant energy and focus on that partnership, not just us and MD4, but also us in industry. We have a tremendous industry capability in our nation, a lot of innovation. So how do we partner with them to really harness that to be able to meet military requirements in that commercial marketplace? So reach out and find me. I'm always around those events and be love to sit down and talk to you.
Perfect. Thank you, sir. And I know you're going to be at Space Symposium here in just a couple of weeks. And
Indeed.
of course, the front door is always there as well. So if
Yes.
Colonel Davis isn't available, which I know, sir, you're a single person dealing with a lot of capabilities as you're just describing. Again, there's a team there at the Space Force, and the front door is part of your team. Sir, final
And the front
question.
door and the front door can connect us, right? So if you go to the front
Perfect.
door, they know how to get a hold of me.
Perfect. All right. That's the way to go then. Sir, the Chief of Space Operations, General Saltzman, has talked a lot about TAC SRT recently. Those efforts seem to be growing. Do you mind expounding on some of those concepts?
Yeah, I touched on this earlier, and well, I'm super excited about all our mission areas. This one, kind of since it's new, it's just so much potential here. The CSO asked us a couple of years ago, you know, there seems to be this capability out there in the commercial marketplace to do data analytics. There's growing availability of commercially available information. Some of it, from the commercial remote sensing capabilities I kind of mentioned a second ago. There's growing publicly available information out there. So how does the Space Force contribute to the fight by seeing how we can harness that? And so we have set up a pilot program called Tech SRT. It's been going on for a little over a year now. Worked with our partners on the Hill and to get some funding to support that and see what is there. And we've shown that there's definitely a there. We've shown that you can take these commercial capabilities and ask through the command commands, the component field commands from the Space Force that are embedded with those component commands, with those command commands, questions. They feed that back through our little op cell we have running this here at SSC out of LA. We work with our commercial partners to go ahead and answer those questions, help them solve those problems that they have. And it's been eye-watering what we'll be able to do. We're just trying to figure out how do we partner with the rest of the community? How do we augment existing capabilities to bring something that wasn't necessarily there as readily or as efficiently as we can provide it using this model? So a lot of activity, like I mentioned earlier, 400 products delivered in the pilot for 75 plus different events. It's getting a lot of traction out there, a lot of excitement.
That's perfect. I think people are going to want to hear more about that specifically, Colonel. So I'm looking forward to a future opportunity where we can discuss that in more
Yeah, I'd
detail.
love to.
in everything you're talking about, the realization is there's no duplication of efforts with organizations within the IC. This is all additive. Everything you're doing is additive to existing architecture. So that's what's really great about what you're working on out there.
Yeah, we have great partnership with NGA. They've helped us shape some things. I think we've helped them think about things differently. They have some commercial data analytics capabilities as well. I think their focus is a little different than ours, and I think that's great that we can partner on that. I'm in regular dialogue with my counterpart there. I know my team is regular dialogue with them, and so any way we can all work together across the whole of government to get after these problems, I think the nation only wins in that case.
Yeah, it's exactly right. Colonel Davis, I can't thank you enough for taking time out of your busy schedule because obviously looking at your architecture and your portfolio, there is a lot going on there at in space sensing. So thanks so much for taking time sharing your story. I look forward to future updates on upcoming podcasts. But sir, thanks for your time. Any closing remarks from you?
No, it's thanks again, Hippie, and what you do for SFA and what you do for Guardians and the Space Force. Super excited to spend some time with you and share the story of all the great work that Space Sensing Guardians out here in LA and other locations that we are doing to get after the fight for the Space Force and to support the nation.
Here it is, folks. Guardian warfighters on the watch. Colonel Davis, thanks so much for your time. Have a great day. Semper Supra.
Thank you.
Whether by land, sea, or air, military dominance is always won by command of the highest ground. The Space Force Association works with industry partners to examine what's in the art of the possible for future capabilities. The SFA provides an opportunity to research, inform, and advocate for a strong Space Force. Show your support by signing up today at ussfa.org.